Okay, I'm making this video because I'm getting sick and tired of seeing scientists and on shows and with all their stupid theories about time travel and time and all this. It seems to me they're just stupid and they're learning what they're learning in school and they think that that is true and there's no possible way it can be true. Okay, this thing about curving things, large bodies curving space time, and that's what pulls things towards them. I'm sick of hearing it. Okay, it's a bunch of bull. All right. There, things aren't curving space and time, and that's why they're getting sucked in towards things. It doesn't make any sense, and I'm going to get really elaborate. I'm going to get really elaborative here. It's not just going to be me stating my frustration. Okay. Um, First of all, things aren't can't be curving something, and that's how they're pulling it in, like a vacuum, like a curve. First of all, you can't have a curve all the way around something. Okay, it's common sense. You, where's the curve in? It can't be a curve. It has to be some type of magnetism pulling things towards it. Okay, everything is based on positive and negative power. Um, there's the ether, or whatever scientists want to call it. Uh, all the undiscovered matter in the universe. That's all this stuff that they say is, they can't find. Well, it's energy. We're living in a field of energy. Okay, and when they're trying to find this matter, it's equalized energy, or at least close to being equalized. That's why they can't find it. When you unequalize energy, you end up with positive and negative. Positive and negative can be a very powerful force. Like, for example, when you have an alternator running and you have to charge something that really needs a good charge, you can barely turn the alternator. But when you're looking in between the magnets that are spinning and the outside, there's an empty gap there. You can't see anything, but there's super high positive and negative forces that put a super drag on it. Positive and negative forces are very powerful, and that's why when you have offsets in the ether, or offsets that create positive and negative forces, you can have it, what seems like uh, solid objects, because the power of positive and negative is so strong. And when you have positive and negative things, you know, what seem like particles, when particles are put into a collider and they go flying off and in different directions and seemingly disappear, that's them going back into energy. Okay, because energy is offset to make particles and atoms and everything, molecules, and the power offset is what makes matter. Anyway, um, gravity is pulling on something else. Looking at notes here because I had to write all this down. I was so frustrated. But gravity is pulling because of magnetic imbalance in power. That's what's causing the pull. Okay? That's what's causing the pull. When you have a magnetic offset, you're going to pull. Okay? So a large object is magnetically offset from a small object. That's what the attraction is. Just like magnets. Okay? Um, and time, there's no such thing as time. Okay? In in my estimation, even if you could supposedly travel through time, it's not going to be in the traditional sense that people think. Going faster than light, you're going to go forward or backward in time. I guess it's one thing is going forward, the other one's going backward. It's not. First of all, there's no such thing as movement or speed, because that's only relative to something else. The only reason why it seems like there's movement is because one thing is relative to another thing. If everything in space disappeared, all matter, except one thing, how would you know if it was moving? You wouldn't, because it's not. It's only moving relative to another object. If there's no other objects, there's no movement. And there is no movement with other objects. Nothing is moving. Okay, so you're not going to go achieve a certain speed and have an effect on time, and time doesn't exist in the first place. How, if it's possible to travel through time or look into another time, it is, you could maybe use a piece of equipment to create a situation where the magnetic reality of a certain point in time, if you use a piece of equipment to create that and then walked into that field, yes, it's possible. You may appear to be in another time in the future, another time in the past. But if you had a piece of equipment that could mimic or create that magnetic field that existed exactly at that moment in time, we are always in the now, but the now is always changing. Magnetic existence at this point is not the same magnetic existence at another point. It's constantly changing. And if you could create a piece of equipment that could mimic that exact magnetic existence, then you may seemingly be in that time period if you walk into that field. Well, people staring at me now because I'm outside. Try to give the house to my wife because I don't want to be bothering her. See if there's anything else I missed here. Oh yeah, when the people did those tests, when scientists did those tests about, like for example, I guess I gotta stop this for a minute. Hello.
1.5 minutes. Time to come in.
Okay. Bye bye. Okay. When particles live longer because they were in a collider, what the scientists are forgetting is that they were affected by the magnetic field that was used to keep them in the middle of the collider and move them through it. Once you affect something by a magnetic field, you've changed its properties. Therefore, it can have different times of existence. If it only lives so long in one magnetic existence, in one magnetic field that is, then if you put it into a different magnetic field, then its properties are going to be different. It may live longer or it may not live as long. Okay? It's only affected by the magnetic field because that's what it creates everything. Offsets in magnetic fields. So that explains the particles living longer in a collider. Okay? Because they're in an extreme magnetic field to keep them positioned in the middle and moving. Okay? Why did they think of that? That is something that's definitely having an effect on the particle or the atom or whatever. Okay? Furthermore, the test where you put something in a plane and fly it near the speed of sound or faster than the speed of sound, and it keeps time different. An atomic clock keeps time different than an atomic clock that's stationary on the ground. When you put something in a weaker magnetic field, like you're flying it, first of all, you're not in the same you're not in the same magnetic field that you were when you were on the ground. The higher you get, the further you get away from the planet, you're in a weaker gravitational field. The gravity is stronger at the ground than it is in the sky, number one. Plus, you're affecting it by motion. When you move through a field, you're affecting the field itself. Okay, so the properties of the atomic clock are not the same. That means that if the properties of the object are not the same, it's not going to keep the same time. Okay? It's obvious. All right? You can't prove something. You can't take away that, act like it doesn't exist, and then say that Einstein was right, because it's not true. You haven't taken everything into consideration. Every particle of an object is affected by magnetics or gravity, whatever you want to call it. But when you put it in a different environment, a different magnetic environment, a different gravitational environment, different magnetic environment, then you have a different object. It may look the same, but it's in a different magnetic environment. Therefore, it is not the same. It's not going to operate exactly the same. And I think that's about it. Okay, but I mean, this idiocy in science is ridiculous. People describing things with mathematics does not make them right. Theories are not, just because you come up with a theory and you base it on certain, doesn't, and you don't take everything into consideration, that makes you wrong. Okay? You can't be right if you don't take everything into consideration. And obviously you got to take the most important things into consideration, which are the ones I just mentioned. Okay? That's it. That's my rant. Thank you.